What's up? Welcome to our second example on optimal stocking in economics. In this video, we're going to work through the same tree cutting problem, except we're going to account for adverse events occurring. Let's go. So suppose we have the same tree cutting problem, except there exists some risk of forest fire, theta, which completely destroys our tree. The Bellman equation for this problem is now as follows, where our value, our capital, is going to be equal to the maximum of picking up that tree, or this discounted value that we'll get in the next period times this probability of this tree going and surviving. That's going to be denoted by 1 minus theta. Obviously, beta here is just going to be 1 over 1 plus r, and our growth rate of our tree is going to be the same. We're now tasked, like usual, with defining the rule for determining when to cut down the tree. So the solution to this problem is going to be as follows. We're going to note that our point of indifference goes and occurs where kt is equal to 1 minus theta times beta v kt plus 1. Rewriting this as follows, just plugging in our values. We're going to also note that our investment beyond our value function at our point of indifference is going to give diminished utility. So we're going to go and just pick up what that value is going to be in the next period. So that's going to be 1 plus g times kt, and that's just going to be multiplied to whatever we have here. A little bit more algebra, and this goes and simplifies down to the following result. Thus, the optimal time to cut the tree is when our interest rate is equal to our probability of our tree surviving and growing minus the probability of destruction. So this was also a simple problem, but we want to know what could we learn from this. The first thing that we can go and learn is that risk can enter problems in a very similar way that discount factors do if there is uncertainty about the future. Risk in terms of harvesting the tree, i.e. let's say you have an inexperienced worker that is going out there that would have to go and pick up that tree. That discount factor will be realized in the present, showing up like this as follows. So I just wanted to go and illustrate these two cases that we have. Obviously the first one we just worked through with reference to uncertainty about the future. And this problem here, I'm just going to leave for you guys to go and solve for uncertainty in terms of the present, in terms of picking up. So I hope this video is insightful and aids in your education on these types of problems. Take care.